My name is Kristoffer Carlsson. I work for Julia Computing, and among other things, I do some of the work on the Julia Package Manager. And today I'll talk about the package registry for the Julia Package Manager. I have a URL to my slides here. I'll give a few seconds if someone want to write it down. I have some links in the slide and so on, and I'll also show this URL in the end of the talk. So first, I just want to show a Julia package installation from scratch. For those of you who were on the earlier Julia talk, this is probably familiar, but for example, if I want to add the Unicode plots package here, I can go into the package REPL mode. And the very first thing that happens is that it installs some registries here, and it installs the general registry. And that is pretty much what the talk will be focused about. But after it has installed the registry, it does some dependency resolution. It's installed the packages that it figures out needs. It does some kind of pre-compiling to make loading the package faster. And when that's done, you can just load the package. And here we have our nice Unicode plot. So that's sort of a very typical workflow with the Julia Package Manager. But here we're going to focus on the registry part of thing. So what is a registry then? Well, if we think about it, what do we need to know for a package installation? Well, we need to know what packages exist, what version of the packages exist, and what dependencies all those package versions have. And in addition, also, what are all these package versions, which ones of them are compatible with each other? So we have this whole graph of packages and dependencies and compatibility. And the registry here is this database that contains all this information. And that's sort of fed into this, what we call a resolver, that finds then a set of compatible dependencies where, in a loose sense, we want the version of all packages to be as high as possible. Of course, if you've seen some of the other resolver talks today, it's much more complicated than that. But in some sense, we want to have high versions of our packages. So Julia's default registry right now is called General. It's hosted at GitHub. It's been not used very long. It's used since early 2018, and then the package manager was rewritten for Julia 1.0. And before Julia 1.0, we had a completely different package manager, and it had another registry called Metadata, which was also hosted at GitHub. It was used from 2012 to 2018. And the design of the current registry, I would say, is evolved from the sort of lessons we learned with using this metadata here for about 6 years. And in this talk, I will discuss the design and implementation of this new registry type, which is the default one is called General, and contrast it to the old one. And I'm mostly going to be focused on like technical details and not so much on like policies and stuff like that. And I just want to say it's possible to have multiple registries. So when I talk about General here, I'm not talking about specifically this registry, but more like the new implementation of the registry. So before I sort of start, I want to see one important difference between the old package manager and the new one. And here I just labeled the old package manager old PKG because it has the same name as the new one. And that is in the old package manager, packages were uniquely defined by their name everywhere. So on internal data structures and so on, it was one package was one name. So you couldn't really handle any name collisions, and you couldn't load packages with the same name into the same Julia session. Another thing was that the old package manager was completely based on Git. So for example, package versions were identified by a Git commit hash, and packages were downloaded via Git clones all the time. In the new package manager, we, as those of you who went to the earlier Julia talk saw, we identify packages via UUID. And a given package cannot directly depend on two packages with the same name, but it's okay to have packages with the same name in the dependency graph. And in this new package manager, we identify a version by their contents. We use a git tree hash instead, which is a content addressable hash. And we download packages as tarballs now. But let's start at the very basic thing. What file format are you using? Well, in metadata, we didn't have really any real file format. There was no file extension, and it was sort of implementation-defined file format. So here I'm just catting one of the files in the old registry, and it shows some dependencies here, and this is a compatibility specimen. And you can see there's no file extension here, so it's just defined by how we read it back then. And it means you need Julia to parse it, or you need to write a custom parser. And it's a very simple format, so it lacks sort of useful things like tables or dictionaries. In the general registry, we just made everything TOML instead. It's a very nice sort of extension for this. You can see an example here when I'm cutting one of the files from the new registry. TOML is pretty nice for humans to read. There's no like excessive indentation and so on, so it feels pretty nice. The second one is how do we lay out the files in the registry? So in the metadata, we had a version folder, and then for every version, there were two files, one which had the dependencies and one which had sort of the commit hash for that version. And you can see if you have a lot of versions, then that's a lot of files and a lot of directories. So this number of files here is scaled sort of as O of the number of versions in the registry. And we used here folders as table keys. So it sort of means because we had such a simple file format, we kind of implemented other things based on the file system instead. While in general, it's just 4 files per package. So it scales as O of the number of packets. And I will go in a bit more about what's in these files later. But for this one, I just want to show like how many files there actually are. And I have a little plot here, which shows here's the number of files in the old registry, which is the orange line, and red is the number of packages. And you can see the number of files increase way faster than the number of packages because it scales with the number of versions. And then here in green is the number of packages in the new registry, and we have some overlap here where we ran both registries. And then blue is the number of files. So we can see it's quite a reduction in the number of files, and it also scales differently. If you would pull this orange line all the way out to here, it would be very high. But even so, if you look here on the blue line, we're still up to like 25,000 files here. So if you divide that by 4, it sort of says approximately how many packages we have in the registry. So even with this new file layout, the number of files became sort of a bottleneck, especially on Windows and on network file system when you create the registry on them. And we found that one thing is that Windows Defender slowed things down a lot. And I put a hack and use comment here, which is always a bit aggressive perhaps, but it said that if Windows Defender was disabled, something that used to take a second to unpack took a couple of minutes. And we also found that true for the package manager. So what we do now is that we just download the registry as a compressed tarball, and then we use a tar library to just untar the file directly into memory. So we never materialize any files on disk. So it's just one file pretty much. But we also support other registries using normal Git repos. So this is mostly done for the general registry. But doing this, we can see this is an installation from scratch on Windows. When we use the old system, we just downloaded the registry like normal. It took about 30 seconds here with, I would say almost all time is just unpacking files from the registry. Moving to this compressed tarball format where we don't make the files, it was about 2 seconds. So that's a big difference for someone just trying out Julia and installing a package. Having something installed in 30 seconds or 2 seconds, it's a big difference in sort of first impression. Another thing I want to talk about is sort of the compression you can do. If you think about different versions of packages, they most often have kind of the same dependencies, even over multiple versions. And in the old registry, we had just one file for each version that listed the dependencies. And they were probably almost identical, these files here. Maybe there was some dependency added and so on, but very similar. And in the new registry, we instead have one file here called compat, and then we store the compatibility using these version ranges. So if you have the same compatibility over many versions, it's just stored one time in a version range, which makes things a lot smaller. And as I said before, in the old registry, we identified a package via the commit SHA. Some issues with that is that the git commit is based on sort of the whole history up to that point. And a version of a package, you don't really care how you got to that point, you just care that this is the version. So it's a bit of a mismatch there. And this also meant that the packages couldn't rewrite their history in a Git repository. There were some packages that had like accidentally checked in very large files. and they wanted to sort of rewrite the history to remove those files from the repository, but that would change all the Git commits, and that would also, so it would invalidate versions stored in the registry. And some people, maybe they don't want to use Git for development, so if you have a system that works with Git commits, you kind of have to do that. And in the new registry, we identified the content hash that does not depend on the history of the repository, it just depends on the actual content of the files. It's not Git specific. I mean, the algorithm we use is the Git tree show algorithm, but you can run that on sort of any folder. And you can also easily verify that you got the correct content based on just the files you have. You don't need a full version like in a Git commit. So if we look at these 4 files that we have for packaging in the general registry, we have a package.toml file, and in that one we have the name, and then we have the UUID. Every package has a UUID. And then we also have a link to the repository here. And this repository links is used if you want to add a package, like if you want to add the main branch of a package or maybe a specific other branch, we would go to use this repository to get it. If you just download a normal version file, we have sort of a community hosted server that it downloads from instead. So in that case, you wouldn't need this repository. Then there's a version.toml file, and in that we just have all the versions and what Git reshow that version has. Then we have a compat.toml file, and in that you can see the version ranges and then what compatibility for the different packages there are there. Now, in theory, since everything is has a UUID, we could, instead of storing package names here, we could store the UUID here. But that means that a human reading this would need to sort of map this UUID to a name, which would be kind of annoying. So instead, we just store names here, and then we have a second file that does the name to UUID mapping there. And this is just for convenience for a human looking through these files. So if we go back to the previous slide, so far this has just been about a single package, how the files have been sort of laid out. Now let's look about how the files are sort of laid out for all packages. So in metadata, we had everything in the top directory. And that's kind of unfortunate. A lot of tools get sad when you have too many files in the directory. If you went to metadata on GitHub, it says like, sorry, we had to truncate this directory to 1,000 files. You have to scroll really far on this one to get to the README and so on. So that was not great. In general, we now shard it by the first letter in the package. So we have a maximum of 26 or something directories here. So that was a big improvement. And in the metadata, the old registry, every package was identified by name. So we could define the path to a package uniquely by this name. And in general, on the other hand, the package is identified by the UUID. But if we would make the package, the path to a package based on the UUID, it also would be kind of annoying for a human. Let's say you want to find the files for some package you have, then you would need to look up its UUID and go to that folder and so on. So instead, there's a top level file here called registry.toml. And in then we have a mapping between all the UUIDs to the path. And then, for example, the package manager, we just look up in here to find out where it will be the files. And since we have this top level file with the path mapping, if we want to redo the sharding, that would be easy because the sharding is not sort of implicit. It's explicit here by this path mapping. Another thing I want to talk about is a registry for local or private packages. It's what I've seen is quite common for companies or research groups and so on to have their own set of local packages. In the metadata workflow, you would need to sort of fork the metadata registry and rebase your own packages on top of it, which is kind of annoying. But in general, the general registry is not special on its own, except it's being there by default. You can add an arbitrary number of registries, sort of a BYOR, where you bring your own registry. And so if I show here, I can just type registry add, and here I'm adding another registry. clones it and it adds it, and I can do registry status to see what registries I have installed. And now if I add a package, you will look through both of these registries to try find it. And now it's also kind of important that packages are identified by UUID now, because if someone adds a package to the second registry here that collides with the first registry, there needs to be a way to handle that, and they will have different UUIDs, so that's how that's resolved. Lastly, I just want to show you the workflow to register or update a package in the registry. So the way you sort of initial registration, there's two different ways. You can just use a GitHub bot and you tag it. You say, hello, Julia Registrator, I want to register. And it replies to you, okay, I made a pull request to the general registry, and with some information here if you want to make a tag and so on. So that's how one way to start it. There's also a web UI at juliahub.com where you can just put a link to your package, and you can give it some options, and then it will also make a pull request here to the general registry. So the bot then opens a pull request with some information. It was created by me, what repository, version, and so on. And if we look at the changes here, the only thing I did was to add a version. So this was the only thing that changed, this version.toml file. There was no difference in the dependencies and so on. So this is the only thing that had to be changed. And then there's another bot here saying that, this looks okay. It will be scheduled for auto merging. So what does looks okay mean? Well, it tries to load the package on Julia, see that that works. It checks the name, there's some naming policies and so on, just making sure that things look reasonable. And then it merges it, and then there's another bot you can install that creates a tag on your repository after it's been merged and put into registry. For new packages, there's a 3-day waiting period to get registered. Some people find that a bit annoying, like why do I have to wait to register my package? But we found it pretty useful because it sort of gives the registry maintainers a little bit of sort of a buffer to see what new packages are getting registered and see that things are looking okay. I think that was it for me. Thank you. And there's the slide shortcut here again, if you want to click the URLs and so on.
Awesome.